the straight line passing through the midpoint of one side of a triangle and parallel to another bisects the third side. So this is the converse of midpoint theorem, okay, the opposite of midpoint theorem. Let us first draw a triangle which will be required to prove this theorem, okay. This is triangle ABC. This is A, this is B, and this is C. Let us suppose this point D is the midpoint of side AB of triangle ABC. Okay. Now DE is drawn. This is E. DE is drawn parallel to BC. Okay. These two lines are parallel to each other. DE is drawn parallel to BC. Let us write the given condition. Given D is the midpoint of side AB of triangle ABC, isn't it? D is the midpoint of side AB of triangle ABC. DE is drawn parallel to side BC. Okay, DE is drawn parallel to side BC of triangle ABC. To prove, so we are asked to prove DE bisects AC. Okay, now let us first understand the term bisect. If I have a line segment of length 10 centimeter and if I bisect this line segment, that means this line segment will be divided into two parts measuring 5 centimeter. Okay, 5 centimeter on either side. That means bisect means to divide into two equal parts. Okay, so if I say DE bisects AC, that means AC will be divided into two equal parts, that is AE will be equal to EC. Okay, that is what we are asked to prove. So DE, we are asked to prove DE bisects AC, isn't it? DE bisects AC, that is AE equal to EC. Okay, length of AE will be equal to the length of EC because AC is divided into two equal parts, isn't it? So let us do the required construction. Okay, construction. Now let me draw a line segment parallel to BA. Okay, let this be point F. This CF is parallel to BA. CF is drawn parallel to BA. Okay, now DE is produced to meet CF at the point F. Okay, this DE line segment DE is produced, extended to meet this line CF at the point F. DE is produced which meets CF at F. Okay, proof. Now we can see BCFD, this is a quadrilateral, isn't it? So BCFD is a parallelogram, isn't it? Because BC is parallel to DF. This is given, isn't it? BC is parallel to DF, parallel to D is parallel to another side. So BC is parallel to DF. This is given, and CF is parallel to BD. This is done by construction. So we can say B is number 1. Okay, BCFD is a parallelogram. Because DF parallel to BC and CF parallel to BD. If opposite sides are parallel to each other, then that quadrilateral becomes a parallelogram. So BC is parallel to DF and CF is parallel to BD. Opposite sides are parallel to each other, so we can say this is a parallelogram. BCFD is a parallelogram. Number 2, we can say CF equal to BD, isn't it? We can say CF equal to BD because CF and BD are the opposite sides of parallelogram, and the opposite sides of parallelogram are always equal. So we can say CF and BD are equal because they are opposite sides of parallelogram. Opposite sides of parallelogram. Okay. Now number 3. But CF must be equal to DA. CF equal to DA because D is the midpoint of side AB, isn't it? D is the midpoint of side AB. That means BD is equal to DA. BD and DA are equal, but CF equal to BD. That means BD and DA are equal. That means CF equal to DA. So CF equal to DA because BD equal to DA. Okay. BD equal to CF, BD equal to CF, and BD equal to DA. That means CF equal to DA because D is the midpoint. This is given. Given D is the midpoint. Midpoint of AB. Okay. Number 4. Now I am trying to prove triangle ADE and triangle ECF are congruent to each other. Okay. In triangle ADE and triangle ECF we have, okay, let us see these parallel lines. CF is parallel to BA. CF is parallel to BA. So if these two lines are parallel to each other and a transversal is drawn like this, okay, CF is parallel to BA, AC is the transversal here. CF is parallel to BA, AC is the transversal. These two lines are parallel and this is a transversal. That means these two angles will be equal to each other. These are called alternate angles, isn't it? So this angle will be equal to this angle. Okay, this is D. This angle will be equal to this because these two lines are parallel to each other and AC is transversal. So this and this angle will be equal to each other because they are alternate angles. Number 1 of 4, okay. Angle DAE, angle DAE of triangle ADE and angle ECF of triangle FEC, okay, ECF will be equal because they are alternate angles. Alternate angles are equal to each other, isn't it? Alternate angles. Similar, number 2, AD equal to CF, isn't it? DA equal to CF. This is already proved. CF equal to DA in number 3, isn't it? This is proved from 3, okay. And number 3 we have, so we have these two lines parallel, CF and BA, and this time we consider DF as a transversal, okay. So we have two parallel lines like this. This time DF is a transversal. DF is transversal. This is D and this is F. This line CF and BA are parallel to each other. DF is a transversal. This means this angle and this angle will be alternate angles, isn't it? Equal. So this angle and this angle, these two angles will also be equal to each other because DF is transversal and BA and CF are parallel lines. So we can say angle ADE ADE equal to angle CFE. Okay, CFE, alternate angles. Okay, now therefore we can say triangle ADE is congruent to triangle ECF. Triangle ADE and triangle ECF. Triangle ADE and triangle ECF are congruent to each other because we have fulfilled the criteria for angle side angle congruency. Okay, since two angles are equal, these two angles are equal, this angle and this angle are equal, and this side is equal. So this angle equal, this angle equal, and this side and this side equal, CF and D are equal. So angle side angle, this criteria for congruency is fulfilled. So we can say triangle ADE is congruent to triangle ECF. That means if triangles are congruent to each other, their all angles will also be equal and their all sides will also be equal. Therefore further we can say AE, side AE of triangle ADE equal to side EC of triangle ECF, isn't it? Equal to ECF. EC of triangle ECF. Side AE of triangle ADE and side EC of triangle ECF will be equal to each other. Corresponding sides of congruent triangles. Okay, congruent triangles. Corresponding sides of congruent triangles will be equal. Therefore proved. So this is the converse of midpoint theorem. I hope you got this.